The internet glance is so far away that it is catching light that has already been traveling for more than 13 billion years. However, the universe has grown, and as a result, more light has been coming in. For the farthest worlds, we're considering back nearly to the Big Bang in time. The vastness of the universe might appear vast, but it began in its entirety from our reference to the singularity. As of now, this is how we might put the Big Bang theory in perspective. Anyway, the James Webb Space Telescope, the JWST, has shed light on significant mysteries concerning the formation and growth of the universe, leaving us speechless. The renowned physicist Brian Cox declared that the significant findings of the JWST could actually alter our perception of the universe as a whole. Join us as we explore these brand new heavenly discoveries that promise to change our comprehension. The James Webb Space Telescope, named after the well-known director of NASA. James E. Webb continues to be a marvel in present galaxy investigation. This telescope stands for a huge mechanical leap forward from its ancestor, the Hubble Space Telescope. Being the result of a cooperative effort by NASA, the European Space Agency, and the Canadian Space Agency. The capabilities of the JWST surpass those of its predecessor. It makes use of cutting-edge technology and a design enhanced for paying attention to the universe in an amazing level of detail. Unlike Hubble, the JWST conveys clear and sharp pictures of celestial bodies far away, primarily working in the infrared range. Its ability to penetrate the astronomical debris and capture divine items that were previously hidden from our sight with its enormous 6.5-meter essential mirror, constructed out of 18 sections of a hexagon. The JWST was diminutive individuals, such as the Hubble's reflector size, situated roughly 1.5 million kilometers away from Earth at the second Lagrange point. It goes around the Sun in equilibrium with the Earth, ensuring a constant and steady view of the universe while looking into the far-off corners of the universe. It involves exploring light years, and it also entails some kind of time travel. The JWST observes with infrared instruments, heavenly objects, and events going back billions of years. The light that comes from these things as a result of the expanding universe moves through a redshift from the apparent range to the infrared frequency, or longer wavelengths. Fortunately, the JWST is able to detect infrared light from celestial bodies at extreme distances, empowering researchers to study the introduction of stars, investigate cosmic system development, and study exoplanet atmospheres. Its most recent, historic discovery entails locating an incomprehensible mass of cosmic systems at the very edge of the universe that can be seen. This finding casts doubt on the veracity of the idea of how things got started, causing us to re-evaluate our key cosmological assumptions. To better understand how we arrived at this point, we should take a short excursion through the history of space investigation. Ancient cultures like the Greeks and Chinese established the framework for comprehending the motion of the planet by observing the bodies of God. Newton's regulations in the 17th century provided an imaginable structure for traveling through space. Midway through the 20th century, Edwin Hubble, an important astronomer who made historic revelations in cosmology and space observational science, discovered the distance. Nebulae were distant, isolated worlds, the Milky Way, changing our comprehension of the size of the universe and its expansion. Hubble's law, which was created by him, showed that galaxies farther away were leaving at a faster rate, providing proof of the expansion of the universe. Space history after World War II was marked by the beginning of exploration. Sputnik and the Soviet Union in a space race as the first artificial satellite in 1957. Yuri Gagarin's 1961 orbital journey and Apollo 11's 1969 moon landing were crucial accomplishments. Jump ahead to 1990, when the Hubble Space Telescope was launched, giving exceptional clarity and amazing perspectives on the cosmos. The journey from ancient observations to the technological wonders of the James Webb Space Telescope showcases the constant improvement in our ability to interpret the universe. It revealed the space without end and altered fundamental astronomy. Concepts. Very example. The HST, or the Hubble Space Telescope, broke the well-known Pillars of Creation image in the Eagle Nebula, revealing a star nursery formed by huge columns of dust and gas. Another important achievement was the Hubble Deep Field, which captured a sizable number of galaxies that appeared in a void patch of space. The HST also dived into the atmospheres of exoplanets, locating organic and water-based component molecules on faraway worlds, making reference to the possibility of zones that are little habitable outside of our solar system. The following emergence of the most closely observed supernova, SN 1987A, illuminated the life cycle of enormous stars. These accomplishments firmly established the space telescope's legacy as the basis for the modern world with its dazzling cosmology, remarkable discoveries. Its successor, the James Webb Space Telescope, was launched to further develop the technological developments as well as lessons learned from previous models. Our comprehension of the beginnings of the universe is explained by the most widely accepted theory of the universe's beginning approximately 13.8 billion years ago. The EPAR system, the universe began as a seriously smoldering and dense singularity with rapid expansion, producing matter, energy, and underlying forces. As the universe grew, it cooled, resulting in the atoms, stars, galaxies, and other various structures currently observed. The Big Bang theory also explains cosmic microwave background radiation, the vast scale and element abundance in the world's structure. Despite being widely accepted now, the Big Bang theory faced doubt and difficulties in its earliest days. There were other models, like the steady-state theory, that proposed a universe without any predetermined beginning and concerns regarding the supporting evidence. Initial expansion of the singularity and anomalies were observed. Most of these objections were addressed over time, and an important piece of evidence appeared as a result of the discovery of cosmic microwave background radiation in 1965, aligning with Big Bang predictions. WINE system, space missions like COBE and WMAP, alongside technological advancements, further substantiated the theory. The James Webb Space Telescope, which includes advanced infrared instruments, can examine the cosmic dust and capture the oldest light in the universe, observing the formation of objects shortly following the Big Bang. Its infrared capabilities enable it to focus on regions where stars are made, celestial kindergartens, and star formation hidden from optical telescopes. The JWST is able to detect cooler FICAL expression. The infrared range further expands the JWST's ability to conduct investigations. The telescope can look into things that would otherwise be concealed or unnoticed. The JWST supplements optical telescopes, like Hubble, by improving the capacity to detect and be sensitive to ultraviolet light. This capability makes it possible to dig and look further into space, deeper into the past of astronomy, bringing to light occult astronomical wonders and offering a more comprehensive perspective of the universe's development. The JWST serves as a doorway into the previous phases of evolution in the universe. Recently, it disclosed something so mind-blowing that it might make you think twice about the entire model of the cosmology of the universe. We've discovered enormous, massive galaxies at the outermost reaches of the observable universe. These antiquated galaxies, only a few 100 million years after the Big Bang, the dawn of space, existed. The baffling aspect is that we don't know how such enormous structures formed so early in the history of the universe. This revelation might cause us to reevaluate our understanding of the formation and evolution of galaxies in the early universe. Investigating early galaxies is important for deciphering the mysteries of cosmic origins. The JWST can increase insights into the way stars, galaxies, and planetary systems arose and evolved over thousands of years. These observations also contribute to broader questions regarding the fundamental character of the universe. including its composition, structure, and the forces governing its evolution. Throughout its time, the Hubble Space Telescope was groundbreaking, but it was limited in its ability to observe the early universe. Its primary restriction was its inability to effectively see through cosmic dust and locate the infrared light emitted by ancient galaxies. Older telescopes relied on ultraviolet and visible light observations, which made it difficult to examine the origins of the universe, where these wavelengths are absorbed or distorted by interstellar dust and gas. The James Webb Space Telescope represents a significant advancement in our understanding of galaxies from the universe's early stages. Unlike its predecessors, the JWST can observe celestial objects that originated hundreds of millions of years after the Big Bang, using its sensitivity to infrared light and advanced imaging capabilities. The JWST has discovered numerous ancient galaxies, providing incredible clarity and detail in understanding the evolution of the universe. Preliminary results from JWST observations have sparked waves in established models for the universe. Numerous aspects of current theories are challenged by detailed data, resulting in cosmologists reconsidering fundamental guiding principles for our understanding of the structure and evolution of the cosmos. Discrepancies between observed data and theoretical predictions have brought about intense debates within the scientific community. The JWST observations revealed a larger number of galaxies in the beginning of the universe than anticipated by existing models, suggesting a more rapid and complex process of evolution. Some observed early galaxies appear more developed than anticipated, challenging conventional models predicting slower development. The discovery of an unfathomable mass of galaxies challenges the presumed order and distribution of massive structures, revealing a cosmic web that is more complex and dense than previously thought. These observations provide fascinating options and questions for further investigation. The existence of massive structures challenges early models of cosmic structure formation, causing scientists to improve models for a more complete explanation. Understanding how such massive structures came together immediately following the Big Bang is a puzzle that requires an explanation that does not go against basic principles of cosmic theory. Pronounced differences in the conditions of the early universe, in contrast to predictions made using existing models, have also been revealed. These differences could suggest processes that were physically unknown before, unexpected conditions, or unidentified cosmic occurrences. In simple terms, these discoveries have prompted scientists to reevaluate and enhance our models of the universe. Currently, all we can do is declare that additional research is required to incorporate these unexpected observations into a more comprehensive understanding of the universe. Initial observations frequently offer exciting glimpses into the universe, but in-depth investigation sometimes reveals differences. For instance, early observations may reveal particular arrangements or properties within distant galaxies that, upon closer investigation, reveal alterations in their structure, composition, or evolutionary pathways. In conclusion, massive phenomena are extremely intricate and need to be thoroughly investigated before we can precisely comprehend their true nature. Spectroscopy, a technique useful for discovering the history and properties of celestial objects, is an illustration. It involves examining the light that is released or absorbed by astronomical objects. By examining the light's properties, spectroscopy offers in-depth information about the chemical composition, temperature, density, and movement of celestial bodies. This analysis helps us understand the origins, development, and contributions of celestial bodies to the universe's tapestry. The JWST has established numerous instances in which observations differed from later investigations. For instance, initial observations of distant galaxies primarily suggested a straightforward structure dominated by lighter components, such as hydrogen and helium, in line with conceptual expectations. However, spectroscopic examination with the JWST revealed fascinating differences in defining elemental signatures, heavier substances, or compounds previously undetected or misunderstood in the early universe. This challenges established ideas about the early universe's chemical composition and the mechanisms accountable for their growth and dispersion over extensive distances. Similarly, initial beliefs regarding galaxies in the early universe were based on preliminary observations, indicating a relatively consistent pattern of development and organization. However, more in-depth examinations by the JWST revealed a much more diverse and complex array of chemical compositions in these galaxies.